really quickly, let's think about what are the 4 different methods that we know how to solve quadratic equations. What's one way we can solve a quadratic equation? Quadratic formula. Good old quadratic formula. Okay, works every time if you use it right. Okay, what's another way? Completing the square also works every time. Maybe just a little bit more tricky in practice as opposed to the quadratic formula. Okay. We can use the square root property, but that only works when I don't have a linear term, so we don't have a b, and I have an x squared that I can just isolate. And the 4th way was back what we did in Chapter 7, which was by factoring, but that only works when it's factorable. And not every quadratic equation is factorable. Okay? So, when we get to the point in these equations where we end up with a quadratic equation, it is up to you on how you want to solve it. Okay? I am not going to say use this method. So once we end up with a quadratic equation, just go for it. Pick whatever method that you want. If it's factorable, then factor it. If you love the quadratic formula, use the quadratic formula. If you want to complete the square, complete the square. If we're lucky enough that we can use the square root property, use the square root property. Okay? All right, so example number 1. Here's our first equation. We have the equation 1 over x plus 1 over x minus 1 equals 7 over 12. Now, if we remember back when we were solving rational equations, our goal was to get the same denominator in each of those fractions, right? So, in this denominator, I have an x. In this denominator, I have an x minus 1. In this denominator, I have a 12. So I need all 3 of the denominators to have the same thing, which means my first one is missing a 12, and it's also missing an x minus 1. So I need to multiply my first fraction by a 12 and an x minus 1 to keep it balanced so that I'm not totally changing the problem. I'm just strategically picking a value of 1. What I do to the bottom, I must also do to the top. Okay. In the second equation, I already have the x minus 1, so what's missing? An x and a 12. So I'm going to multiply by 12x on both the top and the bottom. And in my last fraction, what am I missing? I'm missing an x and an x minus 1. So I'm going to multiply both my top and my bottom by x times x minus 1. So now if you remember, back when we did our rational equations, once I get all my denominators the same, we can completely ignore them and just focus on the numerator and turn that into our equation. So here, distributing my 12 would get me 12x minus 12. Times 1, which wouldn't affect anything. My second fraction, 12x times 1, would just be plus 12x equals, so now let's take 7x and distribute it. So 7x times x is 7x squared. 7x times negative 1 would be 7 minus 7x. So now I have an x squared term in my equation. It's not going to cancel out because I do not have a 7x squared over here. So should I move all my terms to the right or to the left? To the right. I like that because my quadratic's positive there. Okay, well 12x and 12x would combine to make how many x's? So we really have 24x minus 12 equals 7x squared minus 7x. So now let's start shifting everything over. So I'm going to minus 24x over to the 7x, negative 7x. And then I'm going to add 12 to the other side, which doesn't have anything to add to. So now I get the quadratic. 0 equals 7x squared minus, what is that, 31x plus 12. Okay, quadratic equation. How do you want to solve that? Do you want to try factoring it? Do you want to use completing the square? No, why would that be really ugly? Because I would have to divide everything by 7. Then I would have 31 over 7 for my b, and then taking half of that would be 31 over 14. Then I have to square that, and I don't even know what 31 squared is. So what do you want to use? Quadratic formula? Yeah. All right. So x equals, so negative b would be positive 31 plus or minus the square root of, I still need to know what 31 squared is. 31 squared is 961. Minus 4 times my a, which is 7, times my c, which is 12, all over 2 times my a, which would be 14. All right, so now I'm going to use my calculator to find my discriminant. 961 minus 4 times 7 times 12 is, ooh, that's nice, 625. Why'd that get me excited? Yeah, it's going to be 25. It's a perfect square. So we get 31 plus or minus 25 over 14. All right, so 31 minus 25 is 6. 6 over 14 would reduce to 3 over 7. Go up here. So we get x equals 3/7 for one of our answers. 31 plus 25 is 56. 56 divided by 14 is 4. Okay. Now remember, when we had our rational equations, we had to think about our domain restrictions. Like, what value of x can I not have in the denominator here? 0. X can't be 0 here, and x can't be 1 here. Are any of my answers 0 or 1? No, so I don't have any extraneous solutions. So those are my two answers. So 3/7 and 4. Because they both ended up being rational, that means we probably could have factored this. What is 7 times 12? 7 times 12 is 84. What are factors of 84 that get you to 31? Nope, 84 and 4. Nope, 84 and 6. Nope, 84 and 7. Nope, I don't even know what it would be. Is it 3? Yep, 3 and 28. 3 and 28, put it over 7. So yeah, there it gets our 3/7 and 4. So then it'd be 7x. Oh, they should be both be negatives, huh? Minus 3, x minus 4, which gets us our 4 and our 3/7. Okay. All right. So again, when you get to this point, I don't care how you solve it. That's up to you. You pick whichever method you like best. Again, I wouldn't complete the square there because that would get really ugly. So either try to factor it or use the quadratic formula. All right, number 2. We have 4 all over x minus 1 plus 9 equals negative 7 over x. All right. Well, the denominator of that 9 technically is what? 1. So now I need to get all of my denominators to be the same. So what's the first one missing? It's just missing this x. So I need to multiply by an x, multiply by an x. My 9 needs everything. So it needs an x and an x minus 1. And my 7 is going to need an x minus 1. All right, so once all the denominators are the same, I can completely ignore them and just focus on the numerators. So So x times 4 would get me 4x. 9x distributing would get me 9x squared minus 9x equals, now don't forget this negative 7. Attach the negatives. So negative 7x. Now we have plus 7. All right. Combining like terms on the left gets me 9x squared minus 5x equals negative 7x plus 7. Move everything to the left or to the right? To the left. Good. So I'm going to add 7x to both sides, subtract a 7. So now we get 9x squared plus 2x minus 7 equals 0. Guys, I have no idea why there's a Chromebook out right now. You can put that away, please. All right, what do you want to do? Completing the square again would be kind of ugly because my leading coefficient is a 9. We want to see if it's factorable. 9 times 7 is negative 63. Factors of negative 63 that get us to 2. Wouldn't that just be 9 and 7? So 9 and a negative 7. Put it over 9. So that goes to a 1 and a negative 7 over 9. So x plus 1, 9, x minus 7. It froze on you, huh? It's going to like all of a sudden just shoot up there in one failed swoop. There we go. So that goes to a 1. So we get x plus a 1. 9x minus 7 equals 0. So what are your two solutions?
Negative 1 and positive 7/9.
Good. So negative 1, positive 7/9. Are any of those extraneous? Will they be restrictions on my domain? Here I would have 0 as a restriction. Here I would have positive 1 as a restriction. So here all good. So negative 1, 7/9.
Basically, you just plug it into where they would be and make sure they don't equal 0.
Right. Into the denominators. Precisely that. All right. Okay. Do you want to practice these before we move to word problems or just jump to word problems? Let's go for it. All right. Because we're going to be doing these same exact problems when we do our word problems.